Reflections are usually among the easiest types of transformations. The difficult part is keeping track of what type of reflection you should actually do. So let's take a look. Okay, so reflections come about by introducing negatives into a function. So we're taking the basic function f of x equals square root of x, and I've got it graphed here. And I want to take a look now at f of x equals the negative, or sorry, let's call it g of x actually. G of x equals the negative square root of x. In this case, you can see that the ordered pair 1, 1 is on this graph. However, over here, if x is 1, y is the negative square root of 1, so it's negative 1. And if x is 4, y is the negative square root of 4, so negative 2. So 2, 3, 4, you get negative 2. And furthermore, you can see some more points, but you get the idea that the graph looks like this. And so what it is, it's merely a reflection over the x-axis of the previous graph. Another way to look at this is to say that every y value over here is multiplied by negative 1 over here. So this negative multiplies by every y. So over here, the ordered pair 1, 1 becomes the ordered pair 1, negative 1. The ordered pair 4, 2 becomes the ordered pair 4, negative 2, right? So there are a couple ways to look at reflections. Let's look at another reflection. In this function, the negative's inside next to the x. Anytime you're doing something with the x, I always think about what x value you need to get a certain number. For example, up here, if I want this to be the square root of 1, then x would have to be 1. But down here, if I want x to be 1, x would, or sorry, not x, I apologize. If I want this to be the square root of 1, then x would have to be negative 1 because you already have a negative. Negative times negative 1 gives you positive 1. So this negative in here multiplies each x value by negative. So this negative multiplies by every x. So up here you've got the ordered pair 1, 1. Down here you'd have the ordered pair negative 1, 1. And up here you've got the ordered pair 4, 2. Down here you'd have the ordered pair negative 4, 2. And so you can see that the graph would end up looking something like this. And so this graph is a reflection over the y-axis of the initial graph. So a negative on the outside affects the y values, multiplies by every y, and reflects it vertically over the x-axis. A negative on the inside multiplies by every x because it's near the x, and it reflects it horizontally over the y-axis. That's how you deal with reflections.